We begin our next unit on logarithms. Let's start with the graph of y equals log base 2 of x. This is the logarithmic parent function. The key points to this parent function are 1, 0, 2, 1, 4, 2, and 8, 3. And when we graph this, we have an asymptote at x equals 0. And now if you look, this graph is to the right of the asymptote. This means all the values of x are getting bigger and bigger. But there are no negative values in our graph. So our graph is going greater than our asymptote. So the domain is x is greater than 0, since our asymptote is the line x equals 0. When we look for the range, remember we're looking for the y values. In this case, the y values are going from negative infinity to positive infinity. So the range is all real numbers. Now let's look at the effect on the graph of the logarithmic parent function. In the first function, log base 2 of x minus 1, this minus 1 is inside of the parentheses with x. So this is the h. And remember, this is opposite of the way we think it's moving because of the minus sign. So we are actually moving right 1 unit. So this function is moving right 1 unit from the parent function. Log base 2 of x minus 1. Notice the minus 1 is now outside. It's not inside the parentheses with x. This is the k. So we are moving down 1 unit. In number 3, you can see that there's a minus sign in front of the log. So this is a reflection. In the next example, 4, we have x plus 1 in parentheses. So h had to be negative 1. So this graph moves left 1 unit. In the next example, we have plus 1. Again, this is not in the parentheses. So this is k. This graph moves up 1 unit. In the last example, notice that I now have a 2 being multiplied to the log out front. This is a vertical stretch by 2. So let's graph some logarithmic functions. First, let's start by describing the logarithmic function. In this case, I have a negative sign out front, so we know that this is a reflection. There's a minus 1 inside of the parentheses, so we're going right 1 unit. And there's a plus 2 outside of the parentheses. This says that the graph is moving up 2 units. The range of this function is going to be all real numbers. Now let's find our new asymptote. Since x is moving to the right 1 unit, our asymptote moves right 1 unit. So we moved right 1 up 2. So this is my new starting point. Now let's talk about our old points. The parent function was log base 2 of x. Those old values were 1, 0, 2, 1, 4, 2, and 8, 3. So how did this graph move? Well, let's look at it. The new graph, the new function, there's a negative sign being multiplied to y. But the x value stays the same. So I rewrite all the x values, 1, 2, 4, and 8. And the y values, we multiply everything by a negative 1. Beginning at our new starting point, right here at the red dot, we're going to go to the right 1 up 0. Starting back at the red dot, we're going to move right 2 and down 1. Starting at the new starting place, we're going to go right 4 and down 2. And then we're going to move right 8 and down 3. Now since this is a graph, we can see that it's curving in this direction, but this has to get closer and closer to the asymptote without touching. So this portion of the graph will be looking like this. To figure out the domain, we know that the graph is to the right of our asymptote. So this is going to be greater than, and our asymptote is at x equals 1. So our domain will be x is greater than 1. The asymptote is x equals 1. Let's graph the next problem. Y equals 2 times log base 2 of x plus 3. This 2 out front represents a vertical stretch by 2. And this 3 is outside, so this is moving up 3 units. Let's look at our HK. H is going to be 0 and K is 3. If you remember, the H is where our asymptote is going to be, so here's the line at x equals 0, and at 0, 3 is our new starting place. Now let's look at our graph. The old points are over here in red, and let's look at our new points. What's happening to y? Well, everything is being multiplied by 2. X has a 1 in front of it, so it is not changing. When we're looking for our new directional points, we're only looking for what's being multiplied to x and y. So the x values stay the same, and the y values get multiplied by 2. So 2 times 0 is 0, 2 times 1 is 2, 2 times 2 is 4, and 2 times 3 is 6. Beginning at the new starting place, at the red dot, I go to the right 1, up 0, to the right 2, up 2, to the right 4, up 4, to the right 8, up 6. So we can see that this half of the graph is indeed curving in this direction, but the other half has to keep going closer and closer to the asymptote. And we've already said that the asymptote was x equals 0, but what is the domain? Well, let's look at it. Our graph is to the right. Those x values are getting bigger. X is greater than 0 is the domain, and the range is all real numbers. To finish graphing logarithmic functions, let's write the equation of each of the following, and we're going to use the parent function log base 2 of x. Start with y equals log base 2 of x. Shift left 3 units. So this would be inside the function x plus 3. The next piece here says move up 2 units. So this would be log base 2 of x plus 2. Let's put these things together. Y equals log base 2 of x plus 3 plus 2. Reflect across the x-axis. So if I was to reflect across the x-axis, it would look like negative log base 2 of x. Stretching by a factor of 2 would look like 2 log base 2 of x. Shifting right 4 would look like log base 2 of x minus 4. And shifting down 3 would look like log base 2 of x minus 3. So let's put all of this information together to make our equation. Y equals negative 2 log base 2 of x minus 4 negative 3. Now let's write the equation by looking at the graph. Now remember the parent function, the original parent function, has an asymptote at x equals 0. If you notice, this picture also has an asymptote at x equals 0. That means that the x value inside of the log did not change. So it's not x minus anything or x plus anything. It's just log base 2 of x. So let's figure out what else happened. Remember, the asymptote is 1 unit away from our beginning point. 1 unit away is right here at 0, 2. Let's look back at the parent function. The parent function starts off at 1, 0. The new function starts off here at 0, 2. So that means our graph moved from here 2 units up. And this is an equation, so we need y equals. And this is the equation of this graph. It moved up 2 units.